Sometimes you just can't get to know a scientist until you sit down with them, on a sofa or whatever. I'm Ivy Kupek. I work at the National Science Foundation, and a really cool astronomer named Dan Evans is a program officer here from the Smithsonian Institution, where he normally studies black holes. I've always wanted to know more about this cosmic conundrum, so who better to ask? Hey, Dan.
Hey, Ivy, how's it going?
Pretty good.
Good.
I was wondering if you want to go get a cup of coffee or some tea.
Yeah, sure, let's do it.
Hey, so how's your daughter been? You been building any forts lately with your daughter?
Yeah, I have actually. She's a Lego genius.
So, the reason I was really excited about getting together with you, I had this dream the other night. I don't know if I told you this.
Okay, no.
That I was on the edge of the Earth because we were about to fall into a wormhole. The whole planet was. And it seemed so funny because I was thinking earlier in the day about your black hole research, and then it made me wonder, so what is a black hole exactly then? And if they're black, how do you ever see them?
So a black hole is a region of space and in time that is so infinitely dense that nothing, not even light, can escape for it. Okay? Now that's cool. So that means that black holes, by their very definition, are black. So although the black holes are black, they're remarkably simple objects, and they glow like fireworks, at least in X-ray light, where material falls down. Let's imagine that you're watching water go down a drain. The water starts off, it goes swirls around very, very slowly, and then as it approaches the center of the drain, it rapidly spins. Very, very similar in a black hole. Okay? So as material falls down, it rubs together so ferociously with so much viscosity, and in fact a lot of magnetic field as well, that giant bursts of X-ray flares are released just as the material takes its death plunge into the hole.
How are black holes how do they come to be made?
Oh, I knew you were going to ask me that. That's a really tough question. There are different theories. Let me start by saying that there are two different types of black holes, stellar mass and supermassive. The stellar mass ones have pretty small masses, anywhere between 4 and 20 times that of our sun. The ones that I study, the supermassive, these are the sort of billion to million solar mass beasts. Okay? They probably have very different origins. For the stellar mass black holes, we think that they originated when a star exploded into a supernova and the resulting collapse actually created a black hole. For the supermassive ones, it's anybody's guess, but the best theories are that in the infant universe there were massive halos of dark matter that slowly collapsed underneath their own weight, and because the densities were so high that a black hole formed at the center.
Do they bump into each other or merge with each other and things like that along the way?
Black holes merge quite often, in fact, we think. They sort of spiral around each other in a cosmic dance before coming together and then merging with a ferocious release of gravitational radiation, which we're also trying to detect as well.
Are there a lot of them out in the universe?
Yes, every single galaxy that we know of hosts a supermassive black hole at its heart. Every single one.
Really?
The mass of that black hole is anywhere between 1 million and 1 billion times that of our sun.
Wow.
And we know easily of 300 billion galaxies. And that's just the fraction that we've observed. There are probably infinite numbers of galaxies and therefore infinite numbers of black holes at their hearts.
I know. I've been showed a picture of your daughter during a talk. Young children are sometimes, it's through their eyes that it's best to think about things like black holes even. Am I recounting that correct?
You're right. What I basically always say is that our children make great astronomers because they view the world with such simplicity. And it's actually true. You know, I can still speak to her. She's 2.5 and she'll point at something and say, big truck. Right? It's wonderful. But 2 parameters, right? And black holes aren't much more complicated than that. In fact, they're probably the simplest objects in the universe.
Then why don't we understand them better?
So the devil's in the detail. So black holes are fully and completely described by just 3 quantities: their mass, their spin, otherwise known as their angular momentum, and then their charge. That's it. Now you try describing anything with just 3 parameters. You can't do it.
So what is some of your research involved with black holes? Your research specifically?
What I've really tried to do is to understand how the black holes are spinning. Okay? This is a fundamental test of Einstein's general theory of relativity. Okay? So if we can measure the spin of a black hole and compare it to his predictions, then we can actually begin to understand whether general relativity is correct or whether we need a modification to it. The other thing that I've really spent a lot of time doing is investigating jets. Okay, jets are awesome. Okay, so material falls into the black hole, and just at the vicinity of the black hole, giant jets are shot off. They race outwards from the black hole pretty much at the speed of light, a little bit less, and they can go out many, many, many millions of light years.
What's on the horizon for black hole research?
It's interesting you use that word horizon. So the next big thing with black holes is to image one.
Oh,
Okay?
of course.
This is cool. So
Yeah.
it might seem like a flight of fancy to construct a telescope the size of the Earth. Okay? But teams of astronomers are planning on doing just that. Obviously, they're not going to cover the entire globe's surface with concrete, but they can link together digitally different telescopes across the world to synthesize one giant telescope with diameter that's equivalent to that of the Earth. The idea behind it is that you need such a massive diameter to have such sharp resolution that you can image the actual silhouette of a black hole. It's going to happen. I'm absolutely convinced of it. It'll probably happen within the decade.
Oh, that's amazing.
Yeah,
Close.
so we've just made a massive award within our division to enable one such telescope called the Event Horizon Telescope.
Oh, no kidding.
And we are completely excited about what it's going to do. We're kind of giddy over it. This was so much fun.
It was. We should do this more often.
Anytime.
Well, great.
Bye, Ivy.
Thanks.
All the best.
Take care.
See ya.